Welcome. Thanks for joining us. During this presentation, we're going to build a three-dimensional model using a pencil and a sheet of paper to help you quickly understand the basic astronomy of 2012. Our model only contains three parts: the plane of the Earth-Sun orbit, the plane of the galaxy, and the axis of the Earth. So let's get started. The first thing we want to look at is the orbit of the Earth around the Sun. Imagine the Sun in the middle of a big tabletop, with the Earth always staying on this tabletop as it travels around the Sun in its yearly orbit. This tabletop is called the plane of the Earth-Sun orbit, or the plane of the ecliptic, or more simply, the ecliptic. As you may know, the Earth's axis of rotation is tilted about 23 degrees shy of vertical from the plane of the ecliptic, and it is this tilt that creates the seasons. When the axis is leaning away from the Sun as much as possible, we have the winter solstice and our shortest day. As the Earth continues in its orbit, the axis will no longer point away from the Sun as much as possible, and the seasons change. When it is leaning towards the Sun as much as possible, we have the summer solstice and our longest day. In addition to its motion around the Sun, the Earth is slowly wobbling, much like a spinning top that is not standing straight up. This is the action of precession, and it's what makes the event of 2012 unfold as it does. It takes about 26,000 years for the axis to make one circle. We only need to add one more thing to our picture in order to understand 2012, and that's our Milky Way galaxy. Our galaxy is a huge flat disk with spiral arms that spin around a bulge in the center. From the top, it looks like this, and our solar system is just a tiny dot more than halfway out from the center. From the point of view of Earth, our galaxy always looks like this. If you can imagine the galaxy being flattened all the way, you'd be left with something called the galactic plane. It runs right through the middle of the galaxy, and astronomers track its position precisely. When discussing the galactic alignment of 2012, some people talk about the center of the galaxy, while others talk about the plane of the galaxy. Technically, it is the plane of the galaxy that is directly involved with 2012, but the center of the galaxy is also mentioned. In just a minute, we'll take a closer look at this alignment and see why we need to make a distinction between the center of the galaxy and the plane of the galaxy. Here you see that the plane of the galaxy intersects the plane of the Earth-Sun orbit at an angle of 60 degrees, 30 degrees shy of straight up from the plane of the Earth-Sun orbit. This angle never changes. As you can see, once a year, the Earth orbits up into a position where you can draw a line from the Earth, through the Sun, and into the plane of the galaxy, almost directly towards the center of the galaxy. This is the annual galactic alignment. Here's our three-dimensional model. The half that's lying on the table represents the plane of the Earth-Sun orbit, the ecliptic. The other half represents the plane of the galaxy, which again is always fixed at 60 degrees. As you can see, our pencil represents the Earth's axis of rotation. It's important to note that the axis of the Earth is the only thing in our model that moves. This is what keeps our model simple and easy to understand. The crease in the paper is the intersection of the two planes and always points towards the center of the galaxy. But it doesn't point exactly to the center of the galaxy. It misses by a few degrees. That is why the galactic alignment is correctly stated as being between the Earth, the Sun, and the plane of the galaxy, rather than the center of the galaxy. Now, let's make the top of the pencil go around in a circle while maintaining the 23-degree tilt. Again, imagine that one time around takes 26,000 years. This period of time has several names, and one of them is the Great Year. Here's what it looks like from the front. In just a few seconds, we'll see a diagram of this important view. Since the Earth's axis is tilted 23 degrees shy of straight up, and since the galactic plane is 30 degrees shy of straight up, there is a time during the precessionary cycle when the axis of the Earth is almost directly aligned with the plane of the galaxy. It only misses by 7 degrees. This is when the pencil is closest to the folded half of the paper. Here's what it looks like from above. In just a few seconds, we'll see a diagram of this important view. When we look down on our model from above, we see the top view of the circle of precession and the 4 parts of the great year. The vertical line is our crease in the paper. It's where the plane of the galaxy meets the plane of the Earth-Sun orbit. Again, this crease points almost directly towards the center of the galaxy. Basically, we see that twice during the cycle, the axis is directly over the crease, and twice the axis is exactly perpendicular to the crease. This naturally and equally divides the great year into 4 periods of 6,500 years. It is important to note that without the galactic plane, which makes the crease, each and every point on the entire circle of precession would look basically the same. There would be no naturally occurring points of distinction. But when we add the galactic plane to our model, we see that this gives rise to the 4 naturally occurring points that we are talking about. Let's take a closer look at the axis while it is directly over the crease. As the axis is slowly moving through this position, the winter solstice will occur, and this means that the axis is also pointing away from the sun as much as possible, since this is what makes the winter solstice. This means that on this day, the sun is also on the crease, and that you can draw a line from the Earth along the crease to the sun, and then further out to the plane of the galaxy. So now we see that the event of the axis being over the crease is signified by the simultaneous occurrence of the winter solstice and the alignment of the Earth, the sun, and the plane of the galaxy. Both of these events are very well known to astronomers, since they each happen once a year, but they happen together only once every 26,000 years. As a matter of fact, this event has already happened. At the precise moment of the winter solstice in 1998, the center of the sun was exactly aligned with the plane of the galaxy. And yet, it seems to me that the Maya picked the winter solstice of 2012 because from southern Mexico and the Yucatan Peninsula, the sun will cross the plane of the galaxy as the day unfolds. Although the crossing starts a few hours before dawn, the Maya will witness most of the crossing since it continues during the entire day and finishes near sunset. The brightness of the sun will obscure the Milky Way and the plane of the galaxy, but nonetheless, they will be right behind the sun. This crossing from one side of the galaxy to the other metaphorically represents for the Maya the sun moving from one world into another, or a rebirth of the sun, and it only happens like this on the winter solstice once every 26,000 years. In my opinion, this is why the Maya long count calendar was set up to end on this day. This is the special event of 2012. That concludes this video. Thanks for watching.